Welcome to Modeling Data Relationships. In this session, we're going to talk about how we can build data relationships. And to build relationships between data, we have to understand the entities that we have and how to create reference identifiers to link those entities together. When we create these relationships, there are several different types that we can create. One-to-one relationships, one-to-many relationships, and many-to-many relationships. And then once those relationships exist, we may want them to be unique or to be retrieved more quickly, so we can set up indexes to help us do that. And we may want those relationships to be protected and make sure that their integrity remains intact. So we'll talk about referential integrity. And sometimes when we're working with data that have complex relationships, we may wish to go ahead and create entity diagrams to go ahead and make it easier to see them and understand. So let's go ahead and get started. When we're building data relationships, we're going to have data types, and many times those data types are related to each other. So data usually isn't isolated all by itself. And the more rich or complex our data model gets, the more relationships it will probably have between the data in that data model. And the relationships are often just as important as the data itself. So here we can see an example of a data model, and we might have a simple entity like customer that just has a name, an email, address, and a zip code. But it can have a relationship with something like an order. So customers can place orders, and a customer could actually place multiple orders. So here we have an order entity, which has a description, a due date, and lots of other attributes, and there's a relationship between the customer and that order. And obviously, from all the lines and the diagrams and the other types of things we can see, there are lots of other relationships between the order and many other entities as well. So we'll talk about these as we go through the session. Now, when we start to create relationships, it's important for us to know what the entity's identifier is. So an entity must have an identifier to allow relationships to be created. And inside of OutSystems, the identifier attribute has a red stripe down the middle instead of the regular attributes, which have the blue stripe. That identifier starts by default with a long integer that is automatically numbered. And it's automatically numbered when created because the database can do the auto numbering for us. By default, identifiers are mandatory, and the possible types that they could be changed to could be text, they could be integers or long integers, and sometimes we can actually use another identifier as an identifier type. Now, under the covers, we said that entities become database tables, so the identifier becomes the primary key. And inside of OutSystems, we only support simple primary keys, so there are no composite keys possible. And that means that when we create a customer, by default, we always get an identifier attribute, and there will never be two of these. So there will always be one. We'll be able to tell which one by the red stripe, and then the rest of the attributes will be normal attributes. So why is this identifier important? Well, when we begin referencing other data and trying to create relationships, an entity can reference another entity by its identifier. So if we create an attribute that is of type entity identifier, in this case some other entity, what we will get is an attribute that has the blue stripe and a little black arrow. And that means that it's referencing some other entity that exists. That entity could be mandatory or not, and we can actually have a reference to a static entity. But static entities can only reference other static entities. What this is doing underneath the covers in the database is it's actually creating a foreign key to another table inside of the database. And if we decide that that relationship and that reference identifier isn't mandatory, we would actually enter a null identifier as the default value so that it would still know that something has been set, even though it's set to null, which is basically nothing. So if we look at these in a real example, here we have the order, and we have lots of referenced identifiers. So in the example here, we have the priority, and the priority is an entity attribute, and it's a reference attribute because underneath the covers, the data type of this is the priority identifier. So the priority is another entity. That entity's primary key and its identifier is now going to be a attribute of this order. So priority's attribute and its identifier will tell us what the priority is. So when we figure out when we want to know what the order's priority is, we can go ahead and reference that and figure it out. So once we have these reference identifiers, we can then begin creating the types of relationships that we want. So one type of relationship is a one-to-one relationship. So in this case, as an example, a receipt can belong to one order, and each order should have at most one receipt. So if you think about this, if we have an order and someone wishes to get a receipt for that order and we wanted to see that receipt, then it would make sense that the order's identifier and the order receipt's identifier would be directly linked, and they would be basically the same thing. So for this to work, we often refer to the order receipt as an extension of the order, and they should share the exact same identifier. Mandatory should be set to yes, because if we're going to have an extension, we want it to be filled in. And the order identifier will have to be assigned to the order receipt when we go ahead and create it. So here we can see the order and the order receipt. We can see that it has a ID, but that ID isn't its own ID, it's a referenced ID. So here you can see it a little bit better. We get the red stripe for the ID, but it's a referenced ID because it's not the order receipt's identifier. We've set it to the order identifier. So that helps us create the one-to-one relationship. Now, sometimes when we create these one-to-one relationships, the smaller or extra entity, like the receipt in this case, is sometimes referred to as the extension entity because it's going to use the primary entity's identifier, and in reality, the two entities could be merged. The only reason to go ahead and split them apart might be for performance or when the base entity is read-only. So we're not going to allow any updates to one part, and if we do want to assign and change other attributes, we would put them in the extension. So in this particular case, order and order receipt, the receipt may have a file name and it may actually be a picture. And that would make the order work a little bit slower if we're trying to sort over large amounts of information. So we can go ahead and split that out in a separate entity. Now, besides the one-to-one relationships, there are also one-to-many relationships. So each customer may have many orders, and an order was requested by one customer. So a customer can submit multiple orders. So the order entity will reference which customer it came from. And in this case, we create a requested by attribute, and we set that to the customer identifier. So the reference attribute may or may not be mandatory, but if we don't make it mandatory, then some orders may not actually save which customer made them, and that might create an integrity issue like we mentioned before. But in this particular case, we can see that there's a customer, there's the order, and our entity diagram shows the relationship with the line, and here we see a little triangle or three different lines, and that shows that customer is the one, and a customer can have many orders. And the way it can have many orders is the line actually comes into the requested by. So the requested by is the customer. So this order was requested by this particular customer, and that's how we get to the customer order one-to-many relationship. And down here in that requested by attribute, it's looking for a customer identifier, and it's set mandatory to no. Now, when we do one-to-many relationships, sometimes they're referred to as master detail. The detail entity will reference the master. So the detail will have the reference attribute of type master entity identifier, and an entity can have multiple reference attributes. So as an example of this, obviously the order has requested by. The requested by is that customer identifier, and it references the customer. So in this case, the order is the detail, and the customer is the master entity, because the customer does own the order. That's who placed the order, and that's kind of how that works. And here we can see that the order has lots of other referenced attributes, which mean there are other entities in which it's in a master detail relationship with as well. So here we have the last of the relationships, which is the many-to-many relationship. And in many-to-many, each product may be part of many orders, and each order may have many products. So sometimes we create something like an order product junction entity to go ahead and link the two of these things together. So the reason this is necessary is when you think of the types of relationships we can create, the order can have a one-to-many relationship with something, and product can have a one-to-many relationship with something, but they can't have one-to-many and many-to-many relationships with each other. So what we do is we create order product, and it relates which order is part of the order product and which product is part of it. And then for that particular order where that product is used, we'll determine how many of those things were ordered. So when we create many-to-many relationships, we have to set up this junction entity. And a lot of times the junction entity takes the name of the two entities that it's joining. The new entity will have its own unique ID, so it has its own identifier, but then it'll have reference attributes to just refer to the other entities in the relationship. Now we can also set up a unique index as something that will go ahead and help us find these relationships faster, but it also can make sure that we only have one of them. And we'll talk a little bit about that as we get to the index section. So here in the indexes, we would create an index to go ahead and speed up the data retrieval for certain types of attributes. There is a small cost to creating an index because it'll actually be writing extra information and taking up a little bit of extra storage space. But if this is a way in which we're going to be working with the entity and retrieving it or searching on it by certain sets of attributes, having the reference attributes automatically created as indexes can make things a lot easier. And we can create our own custom indexes as well. So over here, you can see that if we went into order product, and this is the entity editor, and we go to indexes, by default, because there's an order ID reference attribute, there's automatically an index for that. And because product ID is a reference attribute, there's automatically an index for that one as well. But if we wanted to create an extra index for order product, we could say let's index the order ID and the product ID and make sure that any time they are entered that they are unique. And the reason we might do that is to avoid duplicates. So when we think about having an order and having a particular product in that order, if we said that there are 4 computers inside of an order for a customer, well then if there are 4 computers, I wouldn't want to add the computer to another order, because then we'd have to find computers twice and add the 4 computers to 2 more computers, and it may not make a lot of sense. So we want to avoid duplicates, and we can do that by setting the index to unique. So that can help us go ahead and increase the performance and keep things a little bit simpler by enforcing the integrity of the types of relationships that we're trying to create. Now that gets us to the concept of referential integrity. So indexes can help us with the uniqueness of the relationship, but we have something called the delete rule. And if you were noticing when we were looking at the different attributes, they had names and they had data types, and down at the very bottom there was always a delete rule. So when we create reference attributes, that delete rule can be very important. And this gets applied when we're deleting a record from the referenced entity. So in this case, we've been talking about customers and orders. So if we end up deleting a record from a customer, what should we do? And inside of the delete rule, we have 3 different choices. We can protect, which says don't allow the deleting of the record. So customers that still have orders should not be deleted. If we choose delete, then it says delete the record and cascade delete all the things that it references. So if we delete the customer, then we should delete all of the orders as well. And then we also have a choice called ignore, which doesn't do anything because it will not guarantee the referential integrity. So when the customer is deleted, it's not going to protect the order, but it's also not going to delete it. So the order gets kept, but there is no relationship because it's ignoring the fact that although it's referenced, there is no strict relationship between the two. Now, when we use protect or when we use delete, that relationship that's being created by this rule is being enforced by the database, and that may cause extra overhead and cause us to test to see how the performance of those things will actually work. So we could also do these deletes and protects by actually adding logic inside of code while we're manipulating these entities as well. So the delete rule is there, and these are the different settings that we can set, but there are a number of different ways to handle this, and we sometimes have to worry about the performance of those issues. And last but not least, we started by looking at an entity diagram when we were talking about building these relationships. And here you can see a slightly different version of that same entity diagram. So an entity diagram is just a visual representation of the data model. And it is designed by the developer, whoever is creating the model, and it can represent all of the entities with all of the relationships, and it even shows us the delete rules that we just talked about. So here again we have our products and our order products. We have our orders and our customers. We have the receipts and the priorities and the status. So this is almost the exact same data model. And when we are trying to create the data model, we can actually just drag and drop entities onto the palette, and those entities will show up with all of their attributes, so we don't have to type any of that in. And if 2 of the entities have a reference attribute and it can determine what that relationship is, it shows the one-to-many relationship, or it shows the one-to-one relationship with the receipt. And you can see that the different colored lines mean something as well, in that the delete is red. So if we're using a delete rule and we want the order to be deleted, then the receipt should be deleted because it's an extension attribute, which makes sense. Then we set delete and we get a red line. For the protect, we get a dark gray line, and for the ignores, we get a light gray line. And in general, when we create the data model, because the entities are there and the relationships will get created by the editor for us, these are fairly easy to create. The harder part is just to make sure all the lines make sense and it's easy to follow what the data model is trying to show. So we talked a lot about different types of data relationships. We looked at how the entities and the reference identifiers to other entities will go ahead and help us create these relationships. We tried to describe how one-to-one relationships work and how we can set them up. The same thing with one-to-many and many-to-many. And then we talked about indexes and referential integrity to help us make sure that the data models are working properly. And we looked at entity diagrams a little bit so that we can visually see the representation of everything that we're working with. So that's it for modeling data relationships. Thanks for listening.